Hi, so today in this SAT prep video, we're going to be talking about factoring with a pattern and all the different ways you can see one specific pattern on the test. So hopefully you're looking at these because you learned about them in Algebra 2, these different expressions. They both have two terms. That might be something that you're noticing. And there's a difference between them. We're subtracting them. These are called the difference of two squares, And in your class, you learned how to factor them. And remember, when we factor, we're just breaking something up into parts. So hopefully you're remembering that this factor pattern, if it was x squared minus 25, would work out to be x plus 5 and x minus 5. And your teacher might have told you that one way to remember it is it's really the square root of each of the terms. So that would give you x plus 5 and x minus 5. And that each of the binomial results of the factoring is going to give you 1 plus, 1 minus. Well, why is that? That's because if you multiply those two binomials out, the middle term would cancel. So you wouldn't be left with a trinomial. The second one, 4x squared minus 81, even though there's a number in front, they are perfect squares, so you can factor using the pattern. So again, we're going to have two binomials. One's going to be plus, one's going to be minus. And your factors are going to be 2x and 9. So 2x plus 9, 2x minus 9. And there you factored it. A little bit more challenging is when you have a greatest common factor within your pattern. You might not recognize it as dots. So you always want to look, if you have something that has two terms and it is quadratic, so either quadratic meaning raised to the 2 or quadratic form, an even exponent, you're going to want to go through your process to see if it's the difference of squares. So in this case, I see a GCF of 3 can be pulled out, leaving me with x squared minus 25. And so I can keep going with the factors and get 3 times x plus 5, x minus 5. Okay, so that's a little bit about something you learned, the difference of two squares. I like to refer to it as dots, so I'm going to call it dots from here on out. Now, you really are going to want to be able to factor dots quickly and recognize it on the standardized tests. So, number one, always check and ask yourself, is it two terms? Okay, and I guess I should have added, is there a GCF? And last question, is it dots? Is it the difference of two squares? So like this one, I can see it's two terms. There is no GCF, but it's not dots. It is not dots. 4x squared minus 25, it is two terms. There is no GCF, and it is dots. Why? These are both perfect squares. All right, so this difference of two squares on the SAT is going to be something that you're going to have to be able to recognize, and you are going to have to be able to factor. Now, you may have to factor it, though, in unfamiliar ways, and we're going to be okay with that, okay? So always look for the pattern a squared minus b squared, and remember it'll factor into a plus b, a minus b. Now, when you see a plus b or a minus b, you may want to consider that your question may have something to do with the difference of two squares. And I'm going to show you some examples of that. All right, so here's our first example. Sorry, it's a little blurry on this page. It says, if 5 times x squared minus y squared equals 80, and x plus y equals 8, what is the value of x minus y? Okay, so we've got a lot of things going on here. It's not asking you to solve for x, which is what we normally do in all our algebra classes. It's asking you, what is the value of an expression? And that expression looks like it could be part of difference of squares. Well, they gave me this. So one way to think about this is, first, let me see what happens if I factor that. If I do, I get 5x plus y, x minus y equals 80. Now, because they gave me a value for the expression x plus y, they said that it's also equal to 8. It's the same thing as 8. I can take 8 and I can plug it in here. All right, so that gives me 5 times 8 times x minus y equals 80. Well, that actually makes it a little bit easier. 5 times 8 is 40. So I'm basically asking you what x minus y has to be, in order for 40 times it to be 80, well, it would have to be 2. Why? Because 40 times 2 is the same as 80. So that makes x minus y the same as the number 2. And so my answer would be 2. That's not familiar. That's not the way we solve these in your algebra classes. Okay, here might be one that looks more familiar. Which of the following is equivalent to 16s to the fourth minus 4t squared? Okay, so first of all, I have to look at it. It's asking for an equivalence. I look at the answers and I see that I've got 2 binomials, so it's asking for me to factor it. All right, now I look at it and it's quadratic form. It's not exactly quadratic with the exponent of 2, but it's quadratic form. So if I'm going to factor it, step 1 is always to look for a GCF. Now I see a GCF of 4, so I can pull that out and I'm left with 4s to the fourth minus t squared. Now I look, is it dots? Is this a perfect square? Is this a perfect square? And are they being subtracted? They are, so we can follow our factor pattern. Our factor pattern would then give us 2s squared minus t and 2s squared plus t. So just remember when it's in quadratic form to be careful with those exponents. So now I go and I look for my answer, and I can see that I can eliminate this one. I can eliminate this one. I can eliminate this one because they didn't take out a GCF, so my answer is C. All right, which of the following is not a factor of 16x to the fourth minus 81y to the fourth? Again, another one in quadratic form. So don't be scared by that quadratic form. If the exponent's even, then it's quadratic form. All right, so it would help for me to factor it to see which one isn't a factor. And it's 2 terms, both of which are perfect squares. So I can use the dots factor pattern, which would mean I take the square root of everything. That would give me 4x squared minus 9y squared. That would give me 4x squared plus 9y squared. Okay, so now I look, and this is actually quite confusing because, well, 4x squared plus 9y squared is a factor, so I know that that's an answer. But if you look really carefully, you can actually keep going with this. Because, like, in the form that it's in right now, all 3 of these are not factors. So this is actually dots again. So I have to factor it. So that's going to give me 2x minus 3y, 2x plus 3y. Okay, so look at that carefully. 2x minus 3y is a factor. 2x plus 3y is a factor. So 4x minus 9y is not a factor of the polynomial. All right, we're going to just look at a couple more unfamiliar questions so that you're more comfortable, since I know you're probably comfortable with dots. Okay, so here's a great example of a question. In the equations above, A and B are constants. Which of the following could be A? Okay, so if you have watched any of my videos, you know that equal signs means is the same as, which means that we're trying to look for equivalent expressions on each side of the equal sign. Now you can see these expressions are written differently. This is one like unfactored polynomial, and the right side is a factored polynomial. So what I'm going to do is I'm going to factor the left side and see if we can get it in the same or equivalent form as the right side. Now, normally when I factor, I would take out a GCF, but because this expression doesn't have a number on the outside, I'm not going to. So if I factor this side, I'm going to get 4x minus 6 and 4x plus 6. So it's just asking which of the following could be a value of A. Well, A is the number in front of the x, so it looks like it would be 4. All right, let's look at some more unfamiliar type questions. It says in the equation above, C is a positive constant, so that means a positive number, and the graph of the equation in the xy plane is a parabola. So that's telling me this is a quadratic function, okay, and it's a parabola. Now remember, we factor parabolas, and they usually have they can have up to 2 solutions. which of the following is an equivalent form of the equation? There's that equivalence again. They want to say, what's another way for us to write this? Well, it's tricky because it looks like dots, but I don't really know what C is. So remember, if we use the factor pattern, I said earlier that when you factor it, just think of it being as the square root of each of the terms. So x minus y, x plus y. If you think about it that way, well then this can be factored into x plus the square root of c, x minus the square root of c. All right, now you're looking at me, you're saying, I wouldn't even have known to go there. Okay, so a couple things had to have helped me. Number one, I had to see it was two terms. So if it's two terms, even if it's unfamiliar, you're going to have to consider dots. Another thing that could have helped me is looking at the answers. Each answer gave me two factors. And remember, when we have two factors, we're asked to factor it. So those are some of the things that might help you on a question like this, okay? Now, I will say that I would think that some kids might get this wrong by picking C. But I also want you to notice like how close the answers are. They might have picked A or C. Look, they might not have paid attention to the plus and the minus. They could have even picked B if they got it and not noticed the plus or the minus. But in this case, my answer would have to be D. All right. Here's another one similar. In the equation above, g is a positive constant, and the graph of the equation in the xy plane is a parabola. Which of the following is an equivalent form of the equation? Hopefully you're seeing the patterns to these questions now. So I look at it, it's two terms. I would know that one way I could write it would be in factored form. So I can use the factor pattern of the difference of squares to help me. So I know one's going to be plus, one's going to be minus. I might even go to my answers and get rid of A and C because they're not plus and minus. And then I would do x plus the square root of g, x minus the square root of g. All right, hopefully that helps you learn more about the difference of squares on the SAT. Have a great day.